I've mentioned a few times in these series of videos about electricity about series and parallel circuits. Let's take a look at series circuits. So in its simplest form, a series circuit has a source of potential difference. We've then got a component in there, in this case a bulb, but there's just one loop that the current can flow round. And that's our definition of a series circuit. A source of potential difference, so a battery or a cell, that has one loop and one loop only. And consequently, because the current is travelling at the same speed all the way round, we say it has the same current through every component in the circuit. So let's just look at an example. To measure the current in the circuit, we need to put a number of ammeters in there, and they also go in series within the same loop. So if the first ammeter says 2 amps, the second one will also be 2 amps, the third one 2 amps, and the fourth one would equally be 2 amps. The current will be the same all the way around the circuit, and therefore the same through each component, through each bulb within the circuit. However, the total potential difference from the power supply is shared between the components. So let's see what that means. Let's start by saying our power source has 12 volts. If we assume each bulb to be the same, identical, that means that each bulb will receive 4 volts, because 4 plus 4 plus 4, 4, 8, 12, gives what we started. So 12 volts from the power supply is shared between each of our bulbs. However, not all bulbs are the same sometimes. So let's say our voltmeter read 3 volts for this one, 4 volts for that one. The next one would have to be 5 volts, because 5 plus 4 plus 3 gives us our 12. The current, however, is still the same, and if we think back to other parts that we've discussed before about resistance, that means that this one has a bigger resistance than this one because it's got more volts. There's a bigger push in order to keep the current the same at all points around the circuit. Also to mention at this point is that the total resistance of two components is the sum of the resistance of each component. So what does that really mean? Well, top right, we've got a diagram. If we say one of the fixed resistors has 10 ohms and the other fixed resistor has 5 ohms, so the sum of the resistance of each component adds up. So if we wanted to redraw it, we could redraw it with one resistor and just put 15 ohms there instead. So when we have resistors in series, they just add up. The two numbers, the 5 plus 10, give us, in this case, 15. So if we just look at one more example, we've got one fixed resistor with 3 ohms, one fixed resistor with 2 ohms. So if we wanted to redraw it with just one resistor, we could then add those two numbers up and we'd get 5 ohms. And then for memory, it's useful to see an equation. So RT, or total resistance, is then just R1 resistance 1 plus resistance 2. So if we say the 3 ohms is R1, the 2 ohms is R2, the total resistance is just then 5, the 3 plus 2. If there's 3 resistors in series, you just add up 3 resistors, and so on.